Okay, para masabtan na to ang work, so let's apply a sample problem. So natay sample problem number 1 here. So we have a 10 kilogram block shown here, rest on the smooth incline. If the spring is originally stretched 0.5 meters, determine the total work done by all the forces acting on the block when a horizontal force, kanisha 400 Newton, pushes the block up the plane. S is equal to 2 meters. So here we have several force acting sa block, no? Na ay, sa to first, we have a mass. So if there is a mass, there is a weight. So there is a weight acting on this block. Also, naapoy force nga P. This is this one, kaning 400 newtons. Sa pa other force nga gaak sa block, you also have the spring force. So you can see there is a spring force on this side. So ang spring force is always opposite to its displacement. So yung gingon is, if the spring is originally stretched 0.5 meters, determine the total work done by all the forces acting on the block. So originally this is 0.5 meters nga stretch, and then gi-stretch siya into 2 meters. So there is ang motion is paingon man didto, di ba? That is the path of the motion. So ang force sa spring is always opposite sa motion. Why? Because if there's a spring, pag imo nang i-pull, di ba, mo bitad si spring, and then pag imo i-push ang spring, mo push po na siya sa imo. So that is always opposite the direction of the motion. So this is the force of the spring. So we have a force of the spring over here. Unsa pay force nga gaak sa block? We have a normal force, NC. So ato sa i-analyze first, no, from this sample. Pero mas dali na to siya i-analyze if we draw in FBD. But first ato sa i-discuss what is the work of the due to a spring. So, 'di ba, if you have a spring here, and then ato na siya yana, no? So let's say this is the original position of the spring. Pag imo na siya ibitaron paingon diri, let's say we have a gibita di mo siya, then we have a displacement here, ds. So the force is always paingon gino siya dito opposite. Iyan ang bitaron paingon dito. Pag imo po na siyang i-push on that side, so naa siya displacement here, ds. So iya pong force is pagawas na pod gyapon iyang force. So ang work done due to the spring, di ba naman tayo force times distance. Let's say our force sa spring is Fs, then ds. Na integrating here from the first position to its final position. And then ang force sa spring, so di ba if our force sa spring, if you remember, that is just Ks. So what is K? So the K here, this is the spring constant. And then the S is the displacement or the stretching distance or the contraction. So applying the work equation, then we can have an equation equal to negative 1/2 K times the displacement S sub 2 squared minus S sub 1 squared. So sa ito ang sample, problem number 1, let's take note the given problems, the given conditions in another paper for our sample problem number 1. We have a mass of the object equal to 10 kilograms. So ato ang weight ana, so mass times the gravitational acceleration, this is an SI unit, 9.81 meters per second squared. Then atong weight becomes 98.1 Newton. What else? Our original stretch daw kuno. Let's say, ato na lang ng S1, no? That is 0.5 meters. And then, ang final na to nga stretch, let's say S2 is equal to, that is 0.5 meters plus 2 meters, or equal to 2.5 meters. Sa pailaing given na to, we also have a force P equal to 400 Newton. Okay. So, unsay buhaton na to, ani? So, from this, from our sample, it's nice if we can make a FBD from our problem. So, okay. So first, i-analyze nimo di ba if we have a variable force or a constant force. So if you notice, atong force is constant. It's always constant, 400 Newton, and the weight is always 98.1 Newton. So if we draw an FBD here, so unsay gi-ask nato? We were asked about the total work done. Total work done. So if we draw an FBD of the block, so the block is inclined 30 degrees. So we have a weight here. This is the weight, which is equal to 98.1 newtons. So wala may giingon nga ko ano. So ang natay 400 newton nga force di ba diri, which is the P. Wala giingon nga friction. So we and then nakabutang nga friction smooth incline. So a smooth incline means that this is a frictionless. And then what else? Naputay force spring, di ba, if you remember? So ang force spring, since atong motion, if you remember sa drawing, di ba, we have this inclined surface that is inclined 30 degrees, and then this is the block, and then we have the spring here. So we have the force P, and then the weight of the object. So since ang motion is pasaka, so this is the motion, path of the motion, assume. Then atong assume nga path sa force spring Fs is along that side, pa-incline panaog. So that is Fs here, we have the force of the spring here, Fs, and then incline 30 degrees. So sa pay force nga itong naapa dire, we have the normal force, NC. So that is always perpendicular to the surface. So this is 30 degrees. So ato na isolve ang total nga work done on the object. Again, ang motion is paingon ani nga inclination. So this is the motion. Okay. So let's say this is the final position of the object. So ingon niya ni move that is 2 meters from the katong first stretch niya. Let's say ang first stretch niya is nasa dire. So this is 2 meters, di ba? And then at first is na-stretch to siya 0.5 meters. So ang total stretch na to is from the original gyud is 2. So di ba ang first niya nga nahitabo is gibinat na niya ang spring 0.5 meters. So na original length ang spring, gibinat niya og 0.5 meters. Plus gi-apply pa gini ang force para mas madugangan og 2 meters ang binat. So we have a total stretch of 2.5 meters. Okay. So ato ni siyang tagsa-tagsaon. So we have a horizontal component. So we have a delta x. We also have delta y. Actually, pwede po na ito magamit we have also have, here we have the delta s. So ito ang, yes. So say buhaton na to, ang buhaton na to is like this. So ang first ato siyang tagsa-tagsaon. So we have a work done. So ato initial position ano is from this 0.5. So ang work done due to, let's say, the force P. So this is the force P is along the horizontal, di ba? So atong buhaton is ang force P times the displacement along X. So we have a 400 newtons times pila man ang displacement nato along X. So ang initial position niya is 0.5, di ba? And then isaka siya og 2 meters. So kani siya nga displacement, this is for the spring. So ang kay before sa gi-apply og load naa naman sa 0.5. So let's say this is our starting position. So tong delta X from force P is 2 meters, and then what else? The cosine 30 degrees. So 2 meters cosine 30 degrees is just equal to times 2 cosine 30. That is equal to 692.8203 Newton meter. So Newton meter is just equal to joules. So that is 692.8203 joules. Is this a positive or a negative work? Since ang direction ni force P is to the left, and then ang direction ni displacement X is also to the left, so therefore this is a positive work. Next work atong i-solve is, let's say, si work tungod ni weight. Kani siya. So kinisaka man siya. So let's say atong i-denote ang work due to weight is UW, no? So we have the force weight 98.1 Newton times delta Y. So pila mo si kaning delta Y? So the change of a from this initial position niya to its final is just equal to 2 sine 30 degrees. So delta Y man, so ang force is along Y man, so ang ato pong kuan nga distance or displacement is along Y. So the force times the displacement, we have a 98.1 times 2 sine 30, we have 98.1. So we have a 98.1 unit na to is joules. And then is this a positive or negative work? So ang weight na to is going downward, and then ang motion na to is going upward. Therefore, this is a negative work. Sa next na to nga motion, we have a we have a force. Sa patong force na to, we have this force, spring force. So the force due to spring, di ba, atong remember that is negative 1/2 K, and then times S sub 2 squared, final position squared minus the initial position squared. So naay given na to nga spring constant. So ang spring constant na to nga given, which is here, that is 30 Newton per meter. So we have a 30 Newton per meter. So atong i-substitute ang value dire. So we have the work due to the force of the spring negative 1/2 times 30 times. So if you notice ang ato ang mga displacement along due to the force P and due to the weight is, we have a 2 meters. So unsa nga displacement atong gamiton due to the spring. So ang spring is nagi siya original position. Then gi-stretch ra siya og 0.5 meters. So from its original position to 0.5 meters, and then na-stretch siya further to plus 2 meters. So total stretch na to or work sa spring, so si spring is may stretch lang nimo gamay, na ana siya work diretso. So we have a final position is 2.5 meters man, so we apply the 2.5 meters. And then squared minus initial stretch na, that is 0.5 meters squared. So nganong wala tay sine or cosine? It is because since ang direction sa motion is ing ana, and the direction niya sa force is same ra sa direction sa motion. So kani nag-sin cosine ta para ang direction ni force same put sa direction ni displacement. So we will have here an answer of, so that is negative 1/2 times 30 times 2.5 squared minus 0.5 squared. So that is negative 90 joules. So ato nang gibutan diretso ang sign no, naka-negative na ni siya daan because it is always assume that the force of the spring is always opposite to its motion. So this is the work due to spring, the work due to the weight of the object, and the work due to the force P. So pila nga to ang giasa to is total work. So the summation of total work is just equal to the work due to the force P plus the work due to the weight plus the work due to the spring. So work due to the force P, that is 692.8203, and work due to the weight, so that is negative, so plus negative 98.1 joules, then plus the work due to spring, that is negative 90 joules. And so we have a total work of this applied is just equal to 692.8203 plus negative 98.1 plus negative 90. Now we will have an answer of 504.7203 joules. So this is the work done towards the block. Okay? So muna siya, pag dagan force na applied, ato po siyang tagsa-tagsaon para makakuha ta og total work. Now how about sir, nganong walay appeal C and C? So there is no motion along this axis. Ang motion la is paingon dire. Di ba? So paingon dadto, and then so natay weight and then the force P. And then at the same time, always ni siya perpendicular sa displacement. Okay?